In this video, we're going to be going over density and how to use volume formulas and three-dimensional objects to figure out certain values in three-dimensional objects such as mass, radius, length, width, height. So let's dig into what density is. Density is how packed something is, how much material is in something in the space it is provided in. Usually we'll use the formula for density, mass divided by volume. So for our density formula here, we are going to use the formula mass divided by volume. And our mass is usually measured in grams. So our mass might be, let's say, 100 grams. And we would divide that by the volume. So let's say a three-dimensional object takes up 50 cubic centimeters of space. Then its density would be 100 grams divided by 50 cubic centimeters of space, and it would be 2 grams per cubic centimeter. So it's mass over volume, and you can look at this heart to help you kind of remember it. Think about the mass being the top part of that heart, the volume being the bottom part of that heart, and the DMV is someplace we never like to go. So if you can remember DMV, density, mass divided by volume. Our common units we're going to use are grams in centimeters, so grams in cubic centimeters. In liquid forms, cubic centimeters are also measured in milliliters. So let's look at this first example. Water has a density of 1 gram per cubic centimeter. An object will sink if its density is greater than water and will float if its density is less. Will a cube that measures 2 centimeters on each side sink or float if it weighs 5 grams? One of the things we have to look for first is we have to figure out what the density of that cube is. So a cube that measures 2 centimeters on each side is going to look like this. And if it's a 2 by 2 by 2 cube, then its volume is going to be 2 times 2 times 2, or 2 to the third power. And so its volume is going to be 2 to the third power, which is 8 cubic centimeters. We want to know if it's going to sink or swim, and if its density of, if it is going to have a density greater than water, it will sink. And if it has a density that is less than water, it will float. So let's look at its weight. We can also call that its mass in this case. So its mass is going to be 5 grams. And what we'll do is we'll calculate the density of that cube. So the density is going to be the mass divided by volume, and that's going to be 5 divided by 8. 5 divided by 8 in your calculator is going to be 0.625. And that's 0.625 grams per cubic centimeter. Now the question says this is going to sink or float. And since this number is less than 1, the density of water is 1. Since 0.625 is less than 1, then this thing is going to float. If it were greater than 1, it would sink. Let's look at another example. Example 2. A chef fills a container with 52.6 grams of cooking oil. The density of the oil is 0.88 grams per milliliter. What is the volume of the oil in milliliters? So let's look at our formula again. Density is going to be mass divided by volume. And we're given that 52.6 grams, so that's going to be our mass. We're given the density of the oil, 0.88 grams per milliliter, so that's going to be capital D. And we want to know what is the volume of the oil in milliliters. So V is what we're trying to find. We have 2 of the 3 things, so we'll plug in what we have. Our density is going to be 0.88, so I'm going to put 0.88 over here. We're going to set that equal to 52.6 divided by V. Now to solve for V, I'm going to multiply the V up here by the 0.88. So 0.88 V is equal to 52.6. The next thing I can do is divide both sides by 0.88 to get what the volume is going to be. Those will cancel out. And your volume is going to be measured in milliliters in this case. So 0.88 divided out of 52.6 is going to give you, that's going to give you 59.77. So our answer will be 59.77 And since it's in volume, we're going to use milliliters as our unit. So we'll write 59.77 ml for milliliters. Why don't you try this one here? Pause your video, give it a try, and then you can unpause it and check my answer. All right, let's give it a shot. So you hopefully had tried this problem. The question says the density of a rectangular prism is 1.54 grams per cubic centimeter. So I'm given the density. I'm going to write D equals 1.54 G per cubic centimeter. If the dimensions of the prism are 3 centimeters by 4 centimeters by 6 centimeters, what is the mass of the prism? So I'm not given the volume of that prism, but I'm given the dimensions of that prism, the length times the width times the height. So I can calculate the volume really easily. So the volume is just going to be 3 times 4 times 6, since it's a box. A rectangular prism is a box, so that's going to be 12 times 6, which is going to be 72 cubic centimeters. So since I have the density and the volume, I can write my formula, D equals M over V, and substitute the things that I have in for it. So let's plug in what we have. We have 1.54 for your density. We have our mass unknown, so I'm going to write M divided by 1.54. The next thing I can do is I can solve this for M by multiplying up. So 1.54, I wrote 1.54 for the mass, for the volume. Let me fix that real quick. That's actually supposed to be 72. My bad. So we're going to multiply that up by the 1.54. Multiply on both sides. Cancel that out. And whatever 72 times 1.54 is going to be your mass. That'll get you 110.88. Remember that we write our mass in terms of the top letter in your density, so it's going to be grams, 110.88 grams. Let's look at another example. Okay, the question for mass of a cylinder is 900 grams. We'll call that M. If the density of the cylinder is 0.573 grams per cubic centimeters, capital D, and its height is 20 centimeters, H, what is the diameter, lowercase d, of the cylinder? Remember, a cylinder is a circular base with a height. And what we're given in this problem is the height of 20. And we know the mass is 900 and the density is 0.573. So let's look at the density formula that we're going to use. D equals M over V. We should have two of those three things in there. We'll plug in what we know. We're going to plug in for the density 0.573. For the mass, we're going to plug in 900. And we do not know the volume. So we'll put volume on the bottom and we'll solve for it. Like in a previous problem, we're going to want to multiply that up to the other side. So that volume is going to end up being multiplied by 0.573. So we'll say 0.573 V is equal to 900. And then we can divide both sides by 0.573 to get V by itself. Take a moment to divide those out and you'll have your volume, and then we can move on to the next step. Okay, in this case, our volume is going to be 1,570.68. And that'll be in centimeters cubed. But the question's not asking for the volume. The question is asking for the diameter. So we want to find what the diameter of that cylinder is. So since it's a cylinder, the diameter is going to be the distance between the edges of the circles, and the diameter is also going to be twice the radius. So we really need to just solve for the radius and then double it to get your diameter. So let's think about what we're dealing with. We're dealing with a cylinder, And we have to know what the volume of a cylinder formula is. So recall, look back at your formula sheet. Volume is going to be pi r squared. It's the area of the circle multiplied by the height of the cylinder. So we have pi r squared height and the volume. Things that we do know in this problem are the volume. The volume is 1570.68. We do know the height. The height is going to be 20. So we're going to actually plug in those numbers in for the volume and the height. 1570.68 equals pi times r squared multiplied by 20. In this problem here, we'd want to divide by the 20 and divide by the pi to get r squared by itself. So I'm first going to do a little bit of division. It doesn't matter which one you divide by first. So let's say you just want to divide that pi out. When you divide that out, you get you get 499.96. You could round that up to 500 if you wanted to. At that point here, we're going to want to divide by that 20 on both sides. So we're going to put 20 underneath both of those so we can get the r squared isolated. That's going to give you 24.998, which at that point, I'm going to round that up to 25. So that's going to be about 25. And now we can square root it to get the radius, and the radius is going to be 5 because the square root of 25 is 5. So you'll have your radius as 5, in this case, centimeters. Now the question says, what is the diameter? And now I can take that radius and double it. So your diameter is going to be 2 times the radius, which is going to be 2 times 5, which is 10 centimeters. So that's all for number 4. All right, make sure you have all of number 4 done and look at example 5. We'll do this one last. This will be our last problem for the video. So let's look at the question. The density of a cone is with a radius 8 centimeters is 1.25 grams per cubic centimeter. The mass of the cone is 300 grams. What is the cone's height? Why don't you pause and try and see if you can figure the question? All right, hopefully you've had a chance to try it. Let's look at the question. The density of a cone with a radius of 8, we'll mark that as R, is 1.25 grams per cubic centimeters. So that's going to be my density. The mass of the cone is 300 grams. What is the cone's height? So let's start with our classic density equals mass over volume formula. We're going to plug in our density. So 1.25 grams per cubic centimeter is equal to our mass, which is 300. And we do not know the volume. So once again, I'll put a volume down there. We're going to multiply that volume up. So it's going to be 1.25 V equals 300. And then divide by 1.25. And dividing 300 by 1.25 is going to get you 240. And that volume is cubic centimeters. Now the question wants to know what the cone's height is, which means that we're going to go we're going to go back and use the volume formula for that cone. So the cone's volume is going to be 1/3 pi r squared multiplied by height. And you are expected to know these volume formulas, so write them down every time you use them. That'll help you remember what they are. Let's plug in the things we know. We know that the volume is 240, so I'm going to write 240 for V. We know that the radius is 8 centimeters. So I'm going to go ahead and write 8 in place of the radius. Everything else we don't know, so we're going to write 1/3 pi. We square the radius, and we do not know the height. In fact, we're trying to solve for the height. So in this problem here, we want to undo all that stuff that's around it. So what I'm going to do in both sides is I'm going to multiply both sides by 3 to get rid of this 1/3. So I'm going to take both sides of the equation and multiply both sides by 3. That'll cancel that out. So 3 and the 1/3 cancel out. And 240 times 3 is going to be 720. So we'll say 720 is equal to, now we're just left with pi times 8 squared. Well, what's 8 squared? That's 64. So 64 pi times h. Now I can divide both sides by 64. So I'll take that 720 and divide by 64. And that's 11.25. And now I just have pi times h. And the last step is to divide both sides by pi to get h by itself. So 11.25 divided by pi is going to get you about 3.58. So I have our final answer. Our height is 3.58 and our measure for these units are in centimeters. So 3.58 centimeters is the height of this cone. Guys, hope this was helpful for you using density and volume formulas to help interact. Let me make sure that whole problem is displayed. Make sure you have good notes, write that down. Our next videos will go over cross sections and rotations. Thanks for watching.